with the networking protocols, we're going to associate those to the OSI model. And I think that again, at high level, this is just typically the way that we teach it. And let's just kind of buzz through this with relative ease. So at the application layer, which is which layer again? Somebody put it into the chat for me, just to make sure you guys are paying attention. That's correct. Layer 7, good. Yeah. So it's layer 7 of the OSI model, the top layer. That's where the shared communication by the host, so us, that's where that magic happens. And so typically what we'll do is we'll have all sorts of different apps that run within the application layer. You know, probably the most prevalent ones that we use as consumers on our device are over the internet, right? HTTP, HTTPS, IMAP, and maybe POP. Maybe people are still popping. Maybe SMTP. Most people for email are using IMAP nowadays. If you do a lot of stuff with Linux, maybe you're using SSH. But some of these things, it just happens behind the scene, right? Where you won't even know, like DNS and DHCP. Maybe you do some remote administration and remote desktop protocol. Behind the scenes, SNMP, like on Windows networks, version 3 of SNMP here. If you're running Wireshark, that's pretty much all that you see. Besides ARP and RARP commands on Wireshark is SNMP. I mean, it's really, really active on modern networks. And that makes sense, that in a Windows domain is trying to manage the network. And so I say that because, again, at a high level, most of us use the browser on a consistent basis. So like HTTP and HTTPS. And at a high level, that's typically what we see. So let's kind of keep going here. So FTP, you may be familiar with. This typically is for file transfer between making a connection, and it runs over 2 different ports. Remember that I made the analogy of a door. You knock on the door, and the door here, the number of the door is 20 and 21. And so anytime you want to communicate over FTP, you would always communicate over either port 20 or 21, or if you run it FTPS, which is secure, it would run over port 990. Whereas something like SSH, for instance, is typically allows you to encrypt your traffic. So if you want to use SSH, you may run something like PuTTY, F-Secure, but PuTTY is an application that it's open source that runs over port 22, and we use it all the time for administering our LAMP stacks that we run our web servers on. Telnet is not used as much anymore, but it's a way that you can establish communications, especially to like networking devices like switches and router. A lot of them run over port 23. And so Telnet runs over port 23. SMTP is for a mail, and so it stands for Simple Message Transfer Protocol. It runs over port 25 and port 465. So that's a great question, Drew. I used to harp on the ports and the protocols, and force people to memorize all the ports and protocols, the top 20 that we usually see. But usually they don't have questions that are specifically which port is 22, which port is 25, which port is 21. We don't see those on the CISSP. Now, it's implied that you already know this stuff coming into this exam. So it's fair game, but typically, it's not going to be as easy as, hey, pick the port that matches, the protocol. So in the question, it may say something like, you have a service running on port 22, and then it goes into, breaking down into a scenario. And immediately, if you don't know that port 22 is SSH, you wouldn't be able to eliminate two of the answers. So I would say, at a high level, I'm going to give you on the last day, there's usually 20 ports that I recommend that people know for the exam. And so I usually on the last day, we'll give you the ports that I think are going to be on the exam. But they're not as easy as the Security Plus, where it just is, match these ports to the protocols. And so we keep going here. There's a number of different things that run at the application layer, like this thing that's called DNS, which is a big, big deal. DNS. Why is it a big deal? Well, no one, everybody always blames it on DNS, right? Nobody would remember an IP address. What do people remember? They remember a fully qualified domain name, FQDN. And so the domain name does what we call resolves to the IP address. And so if you've ever registered a domain to an IP address, that's exactly what it does. We don't remember the IP address. Humans don't remember the IP address typically. Instead, we remember these things called the fully qualified domain names. Fully qualified domain names. So DNS typically runs over port 53. Port 53. And there's a whole bunch of different services that run. Probably, there's two that are pretty important here. Actually, three that are pretty important. All these are pretty important, but three that are very important. One is the alias. The other one's the mail. Anytime you see an MX record. And then the name server. I will tell you with 100% confidence, somebody just asked if you should know different ports and protocols. I would absolutely 100% know DNS is port 53. And specifically, I would make sure that you realize that the MX record is for mailing, email. So anytime you would see DNS maybe running on port 53 and there's an MX record, the answer would be mail or email exchange. And I'd be willing to bet a paycheck that this is going to be on the exam. So keep that in mind. Another thing that is important here is this thing that's called DHCP. So when you join a network for the first time, this is how the network leases you an IP address. It says, your computer says, yo, I need an IP address. The router or the server, whatever's managing DHCP, would say, hey, I hear you what you're saying. Let me see what addresses I have available, and I will lease you an address for typically 60 days or 120 days or whatever the expiry period of that is. And so that is DHCP, where it dynamically will assign the host the configuration that's needed to speak over the network. And so it gives you the IP address that allows you to join the network, the dynamic host configuration protocol. And so what I would say is, if you don't know this, or if you've never seen DHCP, make a note card. Any of these that you've not seen before, definitely make a note card and write DHCP on the front, define it on the back, and you'd be able to memorize that. By clients and servers, does that mean outbound 68 and inbound 67?
I guess what I'm asking is what's the difference between servers and clients right there?
Oh, so the server would be the one that actually is
Gives out the
leasing it out,
leases, right? Yeah.
DHCP, and then the clients would be all the consumers.
Why are they on different ports?
You know what? I don't know. It's
Okay.
been a while since I've gotten devil in the details there, so I don't know off the top of my head. So this is how DHCP works. Check it out. If you have a pool over on the left-hand side of different IP addresses, the ones in red are already taken. What we can do is a new computer is trying to join the network over here, right? New computer will hit up the DHCP server. DHCP server will then offer back an IP address that's available, and in that case, now this guy will say, "Yep, I want that IP address," and then the DHCP server would say, "Okay, I acknowledge that you want it, and I'm going to go ahead and assign it to you." And then now this guy can begin to talk on the network, which is kind of cool. I mean, if you've never actually researched this or looked at it, whenever you authenticate to a wireless access point, if your phone is shut down and needs to connect back out to the 5G, or if you're on the Ethernet even, this happens a very similar process to this on all different mediums and communication protocols. So POP is something that used to be used a ton, and it stands for Post Office Protocol, and that's what email was sent on a long time ago. Some services like HostGator still use POP. HostGator still uses POP. We had one customer that, man, they were still on HostGator, and what a nightmare HostGator is. If any of you guys use them, I'm sorry for that, but anytime we have a potential new customer that wants to use HostGator or is using HostGator, we run for the hills. HostGator is a service provider for any of you that aren't familiar with them. All right, let's keep on going. So then finally, there's SNMP, Simple Network Management Protocol. And this is how we are able to manage and monitor some of the networking devices. It runs typically over port 161, and the first couple of versions still are available for devices to speak on. But now many of the modern day devices are running the encrypted version of SNMP, and because of that, usually we see any devices that are coming out nowadays are backwards compatible, but typically should try to use the new SNMP version 3 because it is much more secure here. Oh, thank you. Thank you. Thank you, Brian. Appreciate the research there. And so what do we use the most of, right? That's really what it comes down to. So if I was again, just kind of giving you the straight dope, and so far I probably have given you 30 stars, maybe 40 stars that you can stone cold lock. And if you got 100, my goal is to try to give you at least 50 that I'm 100% positive. If you get 100 questions, I'm going to try to give you 50 that I'm 100% positive they're going to be on the exam. Well, this is a few of them here, right? This is a few of them. I'd be super surprised if HTTP, HTTPS, SSL, and TLS are not on this exam. Not on this exam. And so these are the ways of the internet right here. So HTTP is just clear text, what we send over a web browser, whether we're on our laptop or our cell phone or many apps that we consume run over HTTPS. They're secure HTTP. So the difference here is that this is clear text. So if somebody is sniffing the network traffic, they can see everything in the clear that you're doing. Whereas this HTTPS runs with encryption. So it has TLS encryption that runs over SSL. And it's a little weird if you've not been doing this for a little while, but SSL was what we first used that runs over port 443. And then this thing came out called transport layer security. And so SSL began using transport layer security with version 3 of SSL. So anytime that you see port 443, it's SSL running TLS, but it still runs over port 443. And essentially, this creates like a sheath or a tunnel, an encrypted tunnel around your web traffic. So, for instance, if you see that little lock down in the corner of your browser, that's typically what we see for SSL. Any questions on that? Perfect. So here's a list of some of the ports and protocols that you may see on the exam. I'm not going to sit here and tell you you're going to see every one of these. I would highly doubt it. Again, certainly this one, those are usually maybe this one, but so these three protocols, services that are right in the middle with these ports. Again, at super high level. All right, so let's jump into the presentation layer. Again, this is layer 6 of the OSI model. And this is how the data is, that's right, presented. So what format is it in? And many of these are extensions to files, as you can see here. But yeah, the way it is formatted here. And one of the cool things here is that depending on the format, really gives you the extension of whatever piece of data that you're looking at. So that is the presentation layer. The session layer really looks at trying to establishing, maintaining, and terminating any sessions. We can have these three terms right here: simplex, half duplex, and full duplex. What the heck does that mean? Well, I'm glad that you asked, because whenever we use things like network file shares, or structured query language or remote procedure calls, RPCs, at the session layer, they're usually either using simplex, which is from a client to a server, a one-way transmission. So it only goes this way. So it's just simplex. It could use half duplex, where it is able to send two transmissions one at a time. That's the distinction here. Half duplex, one at a time. Or the preferred way that most of the time modern networks work is full duplex, where anybody can send anything at any given time. And so it's simultaneous transmissions. And because of that, it works pretty well. Okay. So a few more here. The transport layer, again, this is layer 4 of the OSI model. That is TCP, UDP, SSL, and TLS. This is where the actual logical connection gets made and networking is done. This is where the networking is done, at least at the higher level, where we're trying to make sure we have a lot of the components ready to go down to the network layer. So let's check it out here. The transmission control protocol, if you're not familiar, TCP is a way that we can get ready to make the connection and pass the data to the networking. There's a bunch of different flags that you likely won't need to know for your exam, but just know that there's ways that we can make things go faster on the network by flagging it. And then we get into making this virtual circuit. And many of you have probably heard of this thing called the three-way handshake. And that is specifically for TCP. And in this regard, down here, it's a SYN. You can see it down here at the bottom, the TCP three-way handshake. It's a SYN, ACK, and an ACK. And so that SYN, ACK, and ACK allows us to make this virtual circuit or connect with this three-way handshake. And so it's kind of like if the first time you meet somebody, you reach your hand out to shake their hand. You're like, yo, hey, I'm a nice person. That person looks at you and is like, man, I see your hand. And okay, I'm going to shake it. And so they acknowledge it. And, you can start to parlez-vous français and, hablas español, or start communicating whatever language you want to start talking. Hopefully over a network, it's data. And so, a bunch of different things happen behind the scenes at the transport layer, where it's acknowledged or it's failed. And if it's failed, then it can actually have different response times. And if it has different response times, then packets can be lost. And so TCP at a high level is one of that. Remember, TCP is a three-way handshake, and there's a virtual circuit, right? That's the most important thing with TCP is this virtual circuit that is made right here. That's the most important thing with TCP. And so the other one that many of us use on a regular basis is typically what we call a best effort UDP, which is user datagram protocol. And so with UDP, this is what most of us use all day long, is it's a best effort. And typically you hear people say it's a fire and forget protocol. This is commonly used. The reason why I say this is probably, if not the most widely used, is because we use this for streaming videos and video games, multiplayer video games. So UDP, not TCP, is used for streaming videos and video games, because TCP will typically verify everything's getting ready to happen for the virtual circuit, but then everything usually happens so fast with UDP that it just pumps data over the wire in a best effort, hoping that you get it. And if you don't get it, then what do you usually see? You usually see it spinning, 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 and then all of a sudden it'll catch up really quickly, and maybe like a cue almost. It's a fire and forget. Sometimes you'll have to rewind that video, but typically, you know, most of the modern day traffic, either on Wi-Fi or 5G networks, run UDP, because people use hella video streaming and gaming. So usually it's running UDP. So that's at the transport layer, TCP, UDP at the transport layer. Whereas at the network layer, somebody asked a question about the network layer. This is where routers typically sit, at the network layer. And so usually all the routing protocols will rear their ugly head. In addition to that, the addressing components will also come into play. And you're like, wow, Ben, this is so much stuff. Well, I mean, the idea is that you at least understand conceptually how a lot of these things work. If I was you, and I was taking this exam, underneath this routing, what I would definitely do is take a look at this right here, and open shortest path first. Open shortest path first. That is typically the way that modern day routers will work. And if you've never seen that before, hold on a second. We'll get into talking about some of these here in a second. It's very likely that you use this, if not daily, on a weekly basis, trying to find locations on your phone to drive to. So if you're using Google Maps or Apple Maps or Waze or whatever you're using, it's trying to find the shortest path first to get you to your destination as quickly as possible. And so we use that on traffic networks, like actual cars, and the same sort of protocols are used in networking as well. And so because of that, most of these are innate to the routing devices. You don't usually have to do much with the routers except the initial setup. And once you set these up the first time, it kind of does its own little thing in the background. But the IP address is in the network layer. The IP address is in the network layer. And if you've not done any IP addressing before, then put your seatbelt on. We're about to go for a little ride. If you don't know what NAT is, then I would definitely make a note card, look that up. And we'll be talking more about IPsec later on this afternoon, but definitely would know these three like the back of your hand. I would bet that these three will absolutely 100% be on your exam. So will either the open shortest path first, or maybe they'll say something about the border gateway protocol and maybe like a firewall attached to the border gateway protocol. And so let's go through and talk about some of these here quickly when talking about the network layer. So typically on a network, when we talk about routing, there's two nodes, and we want to get from one node to another in the fastest time as possible. And so the calculation that happens behind the scenes from device to device typically wants to focus on the minimum distance or the time that it takes to get from point A to point B. And we typically refer to these as hops on the network. How many hops does it take to get from point A to point B? And I want to show you something real quick. I remember the easiest way to think about this to me is, how many hops does it take to get to from one place to another? Easy way that I kind of think of this is this
Mr.
commercial.
Cow,
Yes?
how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
I don't know. I always end up biting. Ask Mr. Fox, for he's much cleverer than I.
Mr. Fox, how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
Why don't you ask Mr. Turtle, for he's been around a lot longer than I. Me, I bite.
Mr. Turtle, how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
I never made it without biting. Ask Mr. Owl, for he is the wisest of us all.
Mr. Owl, how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
A good question. Let's find out. 1, 2, 3, 3.
If there's anything I can't stand, it's a smart owl.
So how many licks
does it take to get to the Tootsie Roll center of a Tootsie Pop?
Let's go ask Mr. Owl. Well, same sort of thing happens in networking. How many hops does it take to get to the other destination? So, the idea is that we can calculate this, and the routing typically does it for us. Usually, there's this thing that's called the time to live between different devices, and we can usually figure that out by doing what's called a trace route. And so on a network, we can figure out the number of hops by tracing the route through the internet on all of these different devices. Now, you're like, yo, this is a whole lot. And you know what? I understand that. Again, there are some patterns that you're probably starting to see, though. One of them is, showing up again, open shortest path first. If you don't already know what that is, I'd make a note card. If you don't know what these are, you likely won't see them on the exam, but I would definitely make a note card for them just in case you do. But let's talk a little bit about how things work in routing. And so with routers, if we have a local area network over here and another one over here near my dome, we'll call LAN 1 and LAN 2. Oh, wow, it just moved. What we want to do is we want to be able to get the backbone here, these ones right here, to talk to each other. And so LAN 1, LAN 2, each one of these might have a border gateway protocol that is associated with each one of them. And so that border gateway protocol would have an egress or an ingress and an egress. So it would have maybe different NICs, network interface cards, maybe a single dual home or single NIC. So one would be facing the WAN, which is the internet, and then the other one would be facing the LAN, which is the intranet. And in order for us to do that, usually we have to have some sort of internet service provider that provides us access to the WAN. And so we can route that internally using what's typically called NAT, network address translation, that's built into that gateway device here, whatever gateway device. And a lot of times those are nowadays firewalls that are built in on the gateway. And internally here, we translate the addresses to an internal IP scheme. And so, externally it may have one IP, but internally it has a whole nother set of IP addresses that we control. And so the WAN would be, the public internet here, and the LAN would be the intranet. These routers will give us these access control lists that typically will work like firewalls. These routers typically work like firewalls. So keep that in mind whenever you're going through and preparing for this exam. There's a bunch of different things that happen with the different routing types. They can have all sorts of connections, depending on how much money you have, right? Most of us have gigi fiber or north of that now, where it's gigabit internet or 1,000 megabytes per second. You can do it just a simple network, test my network speed. I'm just going out to Google here. You can just type in test my internet speed. You can figure out what your internet speed is right here. Let's see what UAH has here. I think I did this yesterday. It's pretty fast. That upload's pretty fast too. That's pretty good. So we know if anybody's having connection issues, it's not my problem. Yes, we definitely have fiber because the download speed and the upload speed are very close to each other. And the idea here is that it gives us that way that we can control what's happening on our LAN very, very quickly, right? Very, very quickly. So keep that in mind. All right, so the last thing that I'm going to talk about here is just some basic details. Again, there's a few that keep showing up here. I would tell you that you should probably know what Telnet is, SSH, and SNMT. Those are things that you should definitely know. In addition to that, knowing the difference between static and dynamic routing is definitely worthwhile as well. Instead of somebody being able to assign their own IP address, which is what static is, you assign your own IP address. Typically, we don't allow that unless it's like in a lab. Usually we just let the network dynamically set it using what we talked about before, DHCP, Dynamic Host Configuration Protocol. And so that is how IP addresses are assigned, and then we let the router magically figure out what the shortest path first is. And again, I've shown you probably 15 slides here. These three keep coming up over and over and over again, right? And so if you're like, yo, hey, just give me the straight dope, I don't have enough time to be doing all this stuff, Ben. Well, I would tell you that if that's the attitude, you're probably not going to pass the exam. But I would tell you that right here, let me put it into the chat. These guys right here, I would absolutely 100% make a note card. For these right here.